Getting up there, hopefully. Just checking this out. I think we're good here. Okay. I don't know if you can hear me on here. Hopefully you can hear me. Right, okay. So this week, welcome back, friends. If you're new to the stream, welcome. If you're coming back, thanks for coming back. This is James King here, the Agent Ultra, having a few technical difficulties today. Today's been one of those days where computers just don't work and they feel like a complete mistake. I was trying to build things. Well, first thing, my phone died. First thing in the morning. It just doesn't work anymore at all, which is great. Which locked me out of all my stuff because of two-factor authentication, so I couldn't deploy anything today. Oh, brutal. Brutal day. No good. But we're still here. We'll stay here. You won't be able to see my wonderful face, but that's okay. Probably don't want to. Got my power juice ready to roll on some Rosby development action. Doing some Haskell. So, last week, what did we work on? We worked on getting things into a kind of working state. I believe we cleaned up a little bit of the config stuff. We got our... We stopped and smelled the roses, if you remember that. And we figured out that... Or I figured out, and you helped me, but we figured out together that our type that we thought was a server wasn't really a server, it was a handler. So it was something masquerade. It was a rose masquerading as something that was not. But that's okay. Handler process, you know, that's kind of where our socket gets dispatched to when we get a connection. And so we fork off a thread to handle socket. And we also ran into a little bit of trouble getting the logging to work from those threads. And so it had to do with basically when we were creating our server thread down here and using bracket. We didn't, the block of the function that was run didn't have the logging T type in the stack, so we couldn't run our logging actions in it, and anything underneath that we couldn't dispatch to that also had logging actions to it. So we did our best to try and put that together and get that to work, and so far it did. So we have a little echo server right now going, where it's just echoing exactly the bytes it's getting back. It's not doing anything terribly interesting right now. And then basically today, I don't know, I'm having a bit of a low day, to be honest, because of the phone thing and the computer thing. But we'll see how far we get today. We might do some houseworking stuff, some housekeeping, basically getting, the code's starting to get a little bit more messy. It's getting a little bigger. Should probably start adding some linting to it. And maybe, I mean, I'll start adding a little bit of readme or something. I don't know. We'll see. The other thing I wanted to work on feature-wise, though, was maybe getting the parser started. So we'll see how we do on that one. Without further ado, if anybody's listening, just let me know my audio's working. I can't see the meters from here because I'm standing at my standing desk today while I'm chatting to you. Okay, so let's see what to work on first. Well, we should probably also get like a backlog of issues going here so that I can remember this stuff because I'm starting to lose track. Okay, let's just remind ourselves how it works first. First, we stack run rosby.exe. Okay. Oh, what is that? What did I do? I didn't do the right thing. Oh no, what's happening? That's not right. I'm not in the right directory, that's what's happening. Of course. That's the kind of day it's been today, let me tell you. I did a little bit of research on this too. We were kind of left up hanging at the end of the stream last week trying to figure out how can we throw sigint to a process in Windows? Answer, you can't. There's a handy little program called Haskell that seems to be the thing that does it. Sort of works okay. So another thing we might want to do to make working on Windows easier is just to write some bash scripts or something to start and stop the server for us. But if we go there and we telnet into our server, localhost, I think it was 1993, we get our echo sacs. So you notice how when I press just the F, I get an F back, I get a J, I get a J back. That's because we're not even waiting for like a line character or anything buffering being sent to the server. We're just echoing back the first bytes we receive. So not a very useful echo server. Maybe we'll fix that. We'll make it take a line or something like that. We're also going to have to talk protocols too once we get into the parser and how clients are going to connect to the server and how they're going to interact with the thing. I thought maybe of using like HTTP as the front end to this thing somehow. That still seems kind of like a good idea because the interactions would be pretty simple. But I had a couple of reservations about it. One being that we wouldn't really be using a whole lot of HTTP. We'd only be using a couple of things to implement our server. And so it would seem kind of heavy-handed to have an entire web server that can handle everything, but we're only using like a really tiny bit of it. The other thing, well, that's pretty much it. It just seems like a little bit heavy-handed. It'd be nice to work with. There'd be some benefits to that too. Like we wouldn't have to write any client libraries. They'd all be kind of done for us. Because pretty much every language has an HTTP client. It's just a thing. Yeah, but there's that thing. Like we'd have to compile a whole web server and use only like a tiny part of it. So mileage may vary. 10292. I think that's the PID. Yeah, 10292. So this is the task kill. See, /. Now this is like how you do switches. It has been a long time since I've done this kind of stuff on Windows because this was like DOS days type stuff. / switches. Cool. Right. So we want to give it the /PID of the process ID. Which 10292 or something like that. Now I've forgotten it. See, this is why I want to do like a script or something to automate this. 10292. There we go. Yeah, okay, /f. This is like, you know, it's kind of like the Linux version, sort of. The POSIX kill force -9. I don't know. That's not going to be too pleasant to work with, so yeah, we're going to want some scripts for that. Okay. So that's how it works. Let us now right. Yeah, okay. Let's do a little bit of hacking. I don't know. Let's make it take a whole line. before echoing back the whole line to us. That'll be a little bit more easy to digest. Okay, so in handler, this is where we handle our connection. We go lift IO and we receive a certain amount of bytes. And instead we want to put those bytes that we receive in somewhere. We want to store them somewhere, basically, and build them up until we get a certain byte. And then, when we get to the byte, we want to echo that back out. Capiche? Capiche. Okay. I'm going to just check to see if our handy dandy library has a function for that already, so we don't go re-implementing the universe and everything. So just open up a new window here. Okay. Network. Byte string. I think it was byte string. I'll go here first. Network.socket.bytestring. That's the one. Right. Send many, receive. Okay, no, it doesn't look like we get any kind of helper methods with that. Okay. Let's try and figure this out on our own. Okay. So our thread is going to basically keep calling itself until we get null input. And then what do? We never get null input because, oh, well, we do get null input when we terminate the connection. So we need basically some kind of local context that we can, some local state for our handler. So we can basically store like a buffer somewhere for our characters. Yeah. Okay, for that we're going to need monad state, and then we're going to have to define what the state is. So let's bring that one in. We got to import it, of course. And then we need to add it to our type. State T, I think. It's going to want another parameter there for our state. Oh, sorry, I added it to socket dispatcher. That should be to the handler. Okay. And this is gross. I don't like the names here already. Okay. So, input buffer. We get a byte string off of there, and we could probably just concatenate it as a giant byte string, at least at first, in our state. I'm not sure if this is like going to be the best approach, to be honest, but we'll see how it goes. So the input buffer could be a byte string. Could also be a vector of bytes. Well, let's just go with that for now. We're going to need to import byte string. I think we have that in our package. Let's just check that quickly. Yeah, we do. Okay. Well, we have it imported here. Data.bytestring is B, so we just have to import the type. Up here. Byte string. Okay. Probably derive equal and show for this as well, which you should normally do for most data types if you can. Helps with debugging and stuff. Okay, input buffer. Yeah. Handler context here. Why don't you like that? Alright, because I don't have it in the type yet. Okay, a reader T context. A state T of handler context. A logging IO. And you can see why they're called stacks. They get quite long. Look at that type. Oof. Okay, so now we've got some state for our function. That gives us access to a few methods. To get the state, put things like that. So if you're familiar with modern state, it should be pretty straightforward. If you're not, don't worry. It's cool. Still pretty confusing, I guess, in some ways. Even if you've been doing it for a while. Eventually it kind of sticks in your noggin. You just have to work with it a few times and just try it out, see how it goes. Make mistakes. You know, you're not going to burn your computer and blow things up if you make a mistake in Haskell. In fact, I don't know, sometimes Haskell makes me feel like a terrible programmer, not because I'm a terrible programmer, although that's questionable, maybe I am, I don't know. But just because, like, when I'm working in other languages that aren't Haskell, that don't have a nice type system like this, I make a lot more mistakes. Whereas Haskell always kind of catches me a little bit. See, like, even right here, down here, it's like, oh, gotta update this code too. Not only do we have to peel off the run reader T, we have to peel off the run state T. I think. Was it exec state? I don't know. Oh, right, because we need to give it an initial state. See? Cool. Yeah, so we need to give... Do we have to give state T though? I forget. Actually, see? Now you gotta look up the documentation. You gotta be like, what does state T take again? Let's just try tacking it on the end. See if that works. So our initial state should be handler contexts. Let's just give the empty. Nah, doesn't like it. Let's clean this up a little bit. What part do you not like? Are we peeling them off the run reader T, run state T, handler? Probably running in the wrong order. Let's try it this way. No? Okay. Hello? Logging. Logging in the middle and down the bottom, then state, then reader. Logging at the bottom, then then state, then reader. Okay. That should be okay. It would be nicer if this type error was a little bit formatted better. So in the expression run chan logging T with actual type reader T, you're getting back a reader T, expected to type handler context to logging T. Actual type handler context to something to something. Okay. So we're still getting a function type in our thing that we're passing to run chan logging. So somewhere along the line we're missing a parameter somewhere. It might be to run state T. So I'm just going to check the documentation on that puppy. Control on .state. I don't know if you can see that. Okay. No, it's MTL. Fine. Okay. Then we go run state. Yeah, okay. So run state does take the initial state. Okay, we just put the initial state in the wrong place. That's okay. Then it returns the final value of state. Well, we don't really care about that though. We don't want to exec the state. We just want to eval. I think we want eval state. Yeah, that's what we want. Eval state T. And that is going to take our handler context. That guy. With an empty. We'll peel off that. And then what do we get? Could match the expected type state T something logging TM1. Handler context takes the state T and yes. Maybe we got the order back. The order, maybe we were right the order the first time. Ugh, okay. Scrolling in Emacs, yeah. Now we got the order messed up completely. Because reader T is getting that. And Let's look at some examples just to make sure that I'm doing this right. Yeah, not state though. We want the doing examples of the transformers version. That's okay. We were trying to use eval state t. Maybe this isn't the right approach. Okay, let's see. When handler gets our handler type out, which is a logging TIO with run reader T. I think that's right. Okay, let's look at this type here. So in the first argument of eval state t, okay, we were expecting our function. Is that correct? We're expecting the state t, yes, I mean, whatever. And, okay. That means you're not expecting this here, you're expecting this as the second argument. Here. So if you're expecting that as the second, the initial state as a second argument, where can I, can't really feed you in. So maybe if I can flip this around, I could do that, perhaps. So flip. Flips lets us reorganize arguments, reorder them. It's probably going to be even more pissed off at us now. Right. That's what flip does. And probably just not using it quite right. No, no, no. Flip doesn't like us. Computer says no. Okay. Probable cause. Yes, that's definitely a good probable cause. Okay, that's how you do that. Run reader T. Now you're having a problem with us because, well, state T was expecting an A. With a state T, we're getting an A something to M. So we're messing up the, we're not connecting together the train tracks properly, kid. That's what's going on here. I guess this is kind of why monad transformers are sometimes annoying. Because the order that they're composed together matters, I guess. Okay, so let's see. State wants a state T. Run reader T is peeling off. What does this one return anyway? This whole expression. I can't check the type of that, can I? LSP. Type. definition. Check. There we go. No, that's definitely wrong. Okay, let's go back to our stack here. Logging should be the last thing. Reader is what we should peel off first. Okay. We have that. Then state, which peeling that off should return a logging T. Peel that off, we should get to IO. Dot composes right to left, so we run handler. To get our handler, to get our reader T type. Okay, so that's okay, that's good. So then we need to run the reader T. The reader T doesn't like it anymore. That shouldn't really matter, too many parentheses. Change these all to apply. Still the same thing. The actual type context to state T. I wonder if the reason why it's not quite working right is that run reader T is our problem. Basically, if we look at the type check, we see that we couldn't match the expected type state T, handler context, blah, blah, blah. So like our eval state is expecting that as its first argument. But reader T is returning a context to state, a function. I wonder if we pull that function out here, we pull that parameter out, you get something else? Yeah, okay. Now this whole thing becomes a problem because, okay, we couldn't actually expect to type logging T M of A with actual type state T. So this eval state isn't peeling off and returning a logging T on the inside. Now why is that? Should be returning our MA when we run it. Okay. I think I got to figure this one out. If anybody's listening, a friend or friends, and you'd like to listen to some music in the background while I'm doing this stuff, let me know. I've been thinking about seeing if there's some kind of stream or something I can add to this to give us something to listen to while we're chilling. Okay, well, when we get stuck, let's cheat a little bit. Let's check for eval state t. Yeah, see, somebody else did flip. Haha. Not uncommon. This one did it right there that way, okay. I want to see something where eval state's stacked with reader and some other stuff. Do we think this one might be? Check this one. It's got math in it. Nope, just controlled on monad state. Okay. Maybe we can do it like this. Ooh, reader to state. Oh, they come up with a function to do it. Okay. Glue. Well, I like it. That's helpful. So it looks like they glued it together so that the arguments line up. See how run reader t returns that A. We just run the A here. So they basically have, how do they have this stacked? Reader that way. Well, that just comes in the library these days. So does that. Okay, let's give it a shot. That's basically what the problem we're having right now. So, sort of. Okay, well, it gives me some ideas anyway. Okay, so let's try and we can define that pretty much anywhere. Reader to state t, some monad m. We're going to take the reader t and return state t. That's a, I think. RMA as well. Okay. Right. So what is this doing? Well, this R's have to be the same. The M's have the same, and the A's has to be the same. So I wonder, because this is usually the reader context. Does that have to be the same too? Yeah, I mean, it can't really be anything else. They have to be the same type. I don't know. Things are starting to look fishy and not good for us here. This might be not the right way to go. Because even if we wanted it, yeah. Yeah. That's the type of it there. All right. Put this little hole here. I really don't like the way this overlay is laid out, to be honest. It's not good. Might turn that off somehow. So our goal here is to take our state we can take the R context, the reader. There we go, bring that in scope. Yeah, okay, so we have that in scope. We have the R in scope and we have the S in scope. The S is also of type R. And so this function just gets that R out of the reader and gives it to the state function. Wow. So we have to give it a reader. So RLS. Yeah, reader 1, reader T, RLS. And then we have to return our state T tuple. Now, Okay. The way we would use this then is that we can get rid of both of these. Use one handler returns a reader. Get rid of that. Oh, no. Not today. Not today. I am missing something very obvious and silly. And I'm just too dang tired to see what it is. That's okay. You don't always win. So what we're going to do is I'm just going to stash this away so we can work on it later. And we'll just do something, we'll just do the housekeeping I was talking about. Oh geez, I need more water here. Ah, power juice, fill me up. Okay, let's stash it. There's something there, but we're not quite seeing the way the types are stacking up quite right. So I'll stash that away. Okay. So another thing we could do today, housekeeping wise, is to add some tooling to our project here to keep things in line. Make sure that I'm not writing the worst code ever. And keep some standards up. So for that, we're going to use HLint. If you have other tools you like, please suggest them. I've heard of people struggling to use other interesting sounding tools that kind of like do auto formatting and stuff. That might be kind of neat, as long as you can, implement the way I think formatting should be done. Kidding. Bike shedding is not very useful. It's not a very useful activity. It just brings you down, brings your team down, makes you feel like a negative Nancy. Nobody likes that. I'm not sure why it's negative Nancy. Maybe we shouldn't call it negative Nancy, but you know what I mean. So I'm going to find a different word for it. We'll come up with our own. Negative Newman. Right, so HLint, yeah, with stack, we can just build it and make it part of our process. So I'm gonna just kind of go over here and we'll just go HLint. Now it's just gonna go to the stackage thing down and build it from. There's a command in stack called install. From what I understand, you kind of want to avoid that one, because if you think about stack like make, and that'll be clear. Pandemic places in the okay, it's going to take a while to compile. So let's talk about part things like that. We're going to have like two major things to contend with. So I mentioned HTTP, and that would be a protocol, right? The hypertext transport protocol. And I guess the reason why it's a protocol is that there's like a serialization part that the socket understands and knows how to read, so it knows how to deserialize messages and parse them into structures and then interpret what those structures mean, the semantics of the protocol, and then it responds with a response. And that also has semantic parts that the client is supposed to parse and understand. And so it's kind of a back and forth. And I'm kind of hesitant about introducing HTTP into our project because, again, it's like a pretty big dependency. Like we're just compiling HLint here, and look, it's taking quite a while. Compiling warp, which is a common web server to use, would add to our build times. So it's a pretty big dependency to take on. Fortunately, writing parsers in Haskell is like super simple for the most part. Writing super performant ones, maybe a little bit harder. And we might need a fairly performant one. I'm not really sure how that's going to turn out yet. But the trade-off, instead of using HTTP, we could also write our own protocol on a socket, which is kind of where we're going right now. Right, so let's say we go with a line-oriented protocol. That means like we're going to read that buffer up until some point. And then we're going to say, okay, we're done reading now. The client has sent us all the data for that request. And now it's time to do something with it. Well, we're gonna deserialize it. We're gonna parse it. We're gonna parse it into a valid structure because we parse, we don't validate. It's just a good quote to shout out to Lexi.